The National Electrical Code, or NEC, does require that aluminum service entrance conductors be coated with an anti-oxidizing grease at the main circuit breaker. This requirement is put in place to help prevent corrosion, which can significantly degrade the performance and lifespan of electrical connections. Aluminum, when exposed to air, naturally forms an oxide layer on its surface. This oxide layer, while providing some corrosion resistance, is also an insulator, meaning it impedes the flow of electricity. When aluminum conductors are connected, this oxide layer can create a point of high resistance, leading to heat generation and potential failure of the connection. The anti-oxidizing grease serves several crucial purposes. Firstly, it creates an airtight seal around the connection, preventing oxygen from reaching the aluminum surface and forming additional oxide. Secondly, it contains conductive particles such as zinc or copper, which penetrate the existing oxide layer and establish a better electrical contact between the conductor and the termination point. Thirdly, the grease helps to displace moisture and other contaminants that can accelerate corrosion. The application of anti-oxidizing grease is particularly important for aluminum service entrance conductors because these conductors are often exposed to outdoor environments and are subjected to varying temperatures and humidity levels. These factors can exacerbate corrosion and increase the risk of connection failure. The main circuit breaker is another critical point for applying anti-oxidizing grease. The circuit breaker is responsible for protecting the electrical system from overloads and short circuits. A poor connection at the circuit breaker can compromise its ability to function properly, potentially leading to equipment damage or even fire. When installing aluminum service entrance conductors, it is essential to follow the manufacturer's instructions for applying anti-oxidizing grease. Typically, the grease should be applied liberally to the conductor before it is inserted into the connector or termination point. The connector should then be tightened to the proper torque specification to ensure a secure and reliable connection. It is also important to inspect aluminum connections periodically for signs of corrosion. If corrosion is detected, the connection should be cleaned and re-greased. In addition to the NEC requirements, local codes and regulations may also specify requirements for the use of anti-oxidizing grease on aluminum conductors. It is important to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. The NEC provides specific guidelines and tables for selecting the appropriate size and type of conductor for different applications. These guidelines take into account factors such as the ampacity of the conductor, the voltage drop, and the environmental conditions. Using the correct size and type of conductor is essential for ensuring the safety and reliability of the electrical system. For example, NEC Table 310.16 provides ampacity ratings for various types of conductors based on their insulation type and installation method. It is important to use this table to determine the appropriate conductor size for a given load. In addition to the conductor size, the type of insulation is also important. Different types of insulation are designed for different operating temperatures and environmental conditions. For example, THHN insulation is commonly used for general-purpose wiring, while XHHW insulation is suitable for wet locations. The NEC also addresses the issue of voltage drop in electrical circuits. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or fail. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, it is important to use conductors that are large enough to carry the load without excessive voltage drop. The NEC also provides guidelines for grounding and bonding electrical systems. Grounding is the process of connecting the electrical system to the earth, which helps to protect against electrical shock. Bonding is the process of connecting all of the metal parts of the electrical system together, which helps to create a low impedance path for fault current. Proper grounding and bonding are essential for ensuring the safety of the electrical system. The NEC also requires the use of ground fault circuit interrupters, or GFCIs, in certain locations, such as bathrooms and kitchens. GFCIs are designed to detect ground faults and quickly interrupt the circuit, which can prevent electrical shock. The NEC is a comprehensive set of standards for electrical safety. It is important to consult the NEC and other applicable codes and regulations when installing or maintaining electrical systems. Failure to comply with these codes and regulations can result in serious injury or property damage. Remember that electrical work should only be performed by qualified individuals who have the necessary training and experience. Firstly, always disconnect the power supply before working on any electrical equipment. Secondly, use appropriate personal protective equipment such as gloves and safety glasses. Thirdly, follow all applicable codes and regulations. Aluminum conductors have specific properties that need to be considered. Aluminum expands and contracts more than copper with changes in temperature. Therefore, connectors used with aluminum conductors must be designed to accommodate this expansion and contraction. Also, aluminum is more susceptible to corrosion than copper, especially in the presence of moisture and dissimilar metals. Using anti-oxidizing grease is a critical step in preventing corrosion and ensuring a reliable connection. When connecting aluminum conductors to equipment, it is essential to use connectors that are specifically listed for use with aluminum. These connectors are designed to provide a secure and reliable connection that will not loosen over time due to thermal expansion and contraction. The NEC provides detailed requirements for the installation of electrical equipment, including the proper methods for connecting conductors to terminals. These requirements are designed to ensure that connections are made safely and reliably. One important requirement is that all connections must be made in a manner that prevents the conductor from being damaged or stressed. This means that the conductor must be properly supported and secured, and that the connection must be made in a way that does not create any sharp bends or kinks in the conductor. Another important requirement is that all connections must be made in a manner that provides good electrical contact between the conductor and the terminal. This means that the conductor must be clean and free of corrosion, and that the connection must be tightened to the proper torque specification. The NEC also requires that all electrical equipment be properly labeled. This includes labeling the equipment with its voltage, amperage, and other relevant information. Proper labeling is essential for ensuring that the equipment is used safely and correctly. In addition to the NEC, there are also other standards and guidelines that may be relevant to the installation of electrical equipment. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for electrical enclosures and other equipment. These standards provide guidance on the proper selection and installation of electrical equipment. The Institute of Electrical and Electronics Engineers, or IEE, also publishes standards for electrical safety. These standards provide guidance on topics such as grounding and bonding and arc flash protection. It is important to be familiar with all applicable standards and guidelines when installing or maintaining electrical equipment. The proper installation and maintenance of electrical systems is essential for ensuring the safety of people and property. By following the requirements of the NEC and other applicable codes and standards, it is possible to create electrical systems that are safe, reliable, and efficient. Remember to consult with a qualified electrician or electrical inspector if you have any questions about the installation or maintenance of electrical systems. They can provide valuable guidance and assistance to ensure that the work is done correctly and safely. Anti-oxidizing compounds are not just for service entrance conductors, but they are also recommended for other aluminum connections throughout an electrical system. For instance, connections at panel boards, disconnect switches, and even lighting fixtures benefit from the application of these compounds. By using these compounds, you are mitigating the risks associated with aluminum oxidation and galvanic corrosion, which can lead to loose connections, overheating, and potential fire hazards. Different types of anti-oxidizing compounds are available, each formulated with specific properties to suit various applications. Some compounds are designed for high-temperature environments, while others are better suited for wet or corrosive conditions. When selecting an anti-oxidizing compound, consider the specific requirements of the application and choose a product that is compatible with the conductor and connector materials. Always refer to the manufacturer's instructions for proper application techniques and torque specifications. The proper application of anti-oxidizing compounds is crucial for achieving optimal performance. Before applying the compound, clean the conductor and connector surfaces thoroughly to remove any dirt, debris, or existing oxidation. Use a wire brush or abrasive pad to prepare the surfaces and ensure a clean, bright finish. Apply a generous amount of anti-oxidizing compound to the conductor and connector surfaces, ensuring that all contact areas are adequately coated. When making the connection, tighten the connector to the specified torque value using a calibrated torque wrench. This ensures a secure and reliable connection that will withstand thermal expansion and contraction. Regularly inspect electrical connections, especially those involving aluminum conductors, for signs of corrosion or loosening. If you detect any issues, disconnect the power supply, clean the connections, reapply the anti-oxidizing compound, and retorque the connectors to the specified values. By implementing a proactive maintenance program, you can prevent potential problems and ensure the long-term reliability of your electrical system. The National Electrical Code is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. It is essential to stay up to date with the latest edition of the NEC and understand the changes that may affect your work. Attend training courses, read industry publications, and consult with experienced electricians to enhance your knowledge and skills. Proper training and knowledge are essential for performing electrical work safely and effectively. Always prioritize safety and follow established procedures when working with electrical systems. Use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. Never work on live electrical circuits unless you are properly trained and equipped. If you are unsure about any aspect of electrical work, seek guidance from a qualified electrician or electrical inspector.